Hello everyone and welcome. Behind me is the 2016 BMW X1, and in this video we're going to be talking about Valvetronic, BMW's infinitely variable valve control system. Now, BMW engines, like this 2-liter turbocharged engine in the X1, operate a bit differently than traditional gasoline engines. In most gasoline cars, when you press the gas pedal, you're changing how much the throttle valve opens, a butterfly valve regulating the amount of air that enters the engine. In BMW engines with Valvetronic, however, a throttle valve is not necessary, and when you press the gas pedal, you're altering how much the intake valves open. There is indeed a throttle valve in these engines, but it is simply used as a failsafe. Under normal operating conditions, the valve will always remain fully open. There's a major efficiency benefit of regulating airflow this way, as it reduces the pumping losses of the engine, particularly at low load operations or any time you're not flooring it. With throttle bodies, you have close to atmospheric pressure on the filter side and a vacuum on the intake manifold side. With Valvetronic, you'll have near atmospheric pressure directly outside the intake valves, and thus the engine does not have as much resistance to pulling in air, making it more efficient. BMW claims this valve train design improves fuel consumption by at least 10% under practical driving conditions. So how does the system work? Well, in order to understand, we're going to look at it with the intake valve fully closed, and then look at it with the intake valve fully open. And so what we have here is the valve train, which is located above the cylinder. Here we have the intake valve, of course, and the intake manifold right here. And so what's happening is we have an electric motor here up top, and so it's attached to a worm gear, which can rotate this eccentric shaft, which you can see has this profile here, which will follow along on this intermediate shaft. Now, the intermediate shaft is acted upon by the camshaft, so it has a spring which is forcing it into that camshaft, and then it will, of course, with this roller, follow the pattern of the camshaft. So as you can see, the cam is at its highest point on its lobe right here, so that means, in any traditional engine, the intake valve should be fully open, but as you can see, it's still closed. And so the reason for that is because on this intermediate arm here in the middle, it has this long flat portion. So as long as this rocker arm is on this flat portion here, it's not going to be acting on the intake valve at all. And so that rocker arm is what's actually going to be opening and closing that intake valve. And so what happens is when you open it, you're going to start to rotate this gear this way. And as you can see, that profile will push this intermediate arm closer to this camshaft. And so as a result, it's going to rotate it. And as it rotates it, that means this bottom portion here, where it starts to curve, is going to start to push up against this roller. And so here where we have it fully open, you can see it's rotated all the way, and now it's rotated, so now this bottom portion is right up against that roller. That means this part has to be forced down, so it's pivoting here, and it's going to push that down, and as it pushes it down, it opens up that valve. And so because of this profile right here, you have an infinitely variable system between 0 millimeters with it fully closed and 9.7 millimeters with it fully opened. And this was introduced by BMW back in 2001, and even back then they said that they could go from fully closed to fully open in just 0.3 seconds. So they've probably improved that time since then as technology has improved, but going back to the very basics, this is how that worked. Now, there are additional benefits to this system as well. With throttle bodies, once you floor it, you have to wait for the air to travel from the throttle body to the intake valve. By using valves to regulate airflow and already having nearly atmospheric pressure right outside the cylinder, the intake is immediate and thus response is improved. Another benefit at low load operations, the valves will only open about 0.5 millimeters to about 2 millimeters, and this cross-sectional area means that the air-fuel mixture will move rapidly, improving fuel atomization. This also helps with cold starts. Now, you might be wondering, how does the system allow for vacuum-assisted brakes if there's not a sufficient vacuum in the intake manifold? This is handled by a vacuum pump located at the end of the outlet camshaft. Thank you all for watching. If you have any questions or comments, feel free to leave those below.